In these next couple of questions, we have some extensions, one in which we are asked to construct a 45-degree angle, and another where we're asked to construct a 30-degree angle, just given line segment AB. So we'll start with a 45-degree angle. In order to do this, I have to think about what I know about some angles that we know how to construct, and then how I could get it down to a 45-degree angle. So we've learned about these things called perpendicular lines, and we know that perpendicular lines create 90-degree angles. So what's the relationship between 90 and 45? Well, in order to go from 90 to 45, all you need to do is divide by 2. And we now know a construction to create or cut an angle in half. Remember that construction is called an angle bisector. So my first step is to construct perpendicular lines. My second step is to construct the angle bisector. So here, in order to construct a perpendicular line to AB, I'm going to use the perpendicular bisector construction. And I start that by putting my center on A. Now if you look at where my radius is right now, if I do this construction, my big arcs are not going to cross each other. I need them to cross in order to do this construction properly. So I'm going to open up my radius. Again, I like to go 3/4 of the way, and I'm going to swing above and below. Oop. And then I'm going to put that line right in there. I'll call this C and call this D. So now I know that I have perpendicular lines, meaning I have a 90-degree angle. And as we said earlier, in order to go from 90 to 45, all I need to do is bisect the angle. So I have this point, let's say E, where my perpendicular line crosses my given line segment. So my goal now is to bisect angle CEB. I could bisect any of these other ones, any of the other 90-degree angles, but I'm just choosing CEB. So my first step here is to put my center on E. I'm going to close up my radius just a little. Again, it doesn't matter how big it is, but you have to cross both sides of your angle. Okay, so now I have, what are we at? F and G. Now that I have points F and G, I can put my center on one of them, swing a little baby arc. I'm going to open up my compass just a little. Swing my baby arc there, put it on G, swing my baby arc, and now I have point H. I know it's starting to look a little crazy, but remember our goal is to create a 45-degree angle. So now I need to connect E to H. So now I have a 45-degree angle here and a 45-degree angle here. These two angles are congruent to one another because of the angle bisector construction that we just used. So pause this video, try it on your own, and then when you come back we'll look at constructing a 30-degree angle. Now we're going to look at the construction of a 30-degree angle. So just like we talked the last time about how to get a 45-degree angle, my goodness, we're going to talk about how to get a 30-degree angle. So I know how to construct something that looks like this, where all sides are congruent and all angles are congruent. And in one of my previous videos we talked about how big each angle was, what the degree measure was. And remember that all angles in a triangle add up to 180. There's 3 of them that are all exactly the same in this case. So here I know that each angle is 60 degrees. Remember, this makes an equilateral triangle. In order to go from 60 degrees to 30 degrees, well, again, the same thing, divide by 2. So our first step is to construct an equilateral triangle. Then your second step is to construct the angle bisector in order to get a 30-degree angle. So you can see here that I have line segment AB. I ran into some of my space up here, so I'm going to actually construct the equilateral triangle going downwards, just because I have a lot of open space down here. You're welcome to construct it going upwards, it's up to you, but it's just my preference to do it into open space instead of crowded space. So remember, for an equilateral triangle, we need all sides to be the same length. So I put my center on A, my radius on B. Oop. I'm going to dip down, or up in this case, and swing way down. Then I'm going to switch and do the same exact thing. Remember, keep the radius the same, because it's an equilateral triangle where all sides and angles are the same. Same measure, same length. We'll call this point C. Then your next step is to actually construct the triangle, because remember, at this point you have a curvy triangle and that's not cool. So I'm connecting B to C and A to C. So now I have an equilateral triangle where, say, angle B is 60 degrees, angle A is 60 degrees, and angle C is 60 degrees. So remember, after we have the equilateral triangle, our next step is to bisect one of those angles. That way we can go from 60 degrees, divide by 2 to get 30. So here I'm going to put my center on A. You can bisect any of these angles that you want to. I'm just choosing A because it's there. Okay, so center on A. I'm going to close up my radius sum. That way I can I can draw an arc that crosses both sides of my angle to create intersection points D and E. Once I have D and E, I can now use those to finish the angle bisector construction. So I'm putting my center on E, and I'm swinging a baby arc out here. I'm going to put my center on D and do the same exact thing without changing the radius. And now I have point F. Now, in order to finish this construction, again, we have to connect our vertex A to our intersection F. So I'm just lining the straight edge up. And now I have two angles that are both 30 degrees.